Mhm. Hi, welcome to Coreform. Welcome to our webinar, Why Engineers Choose Coreform Cubit for Third-Party Solvers. Today, we're going to be talking about Coreform Cubit, and specifically, this is aimed at those of you who are evaluating Coreform Cubit as a tool for your own use. And there are lots of meshing tools available, and so this webinar is designed to help you decide if Coreform Cubit is the right one for you to use, or if not. We're going to talk about the supported CAD and mesh formats. We're going to talk about the history of Cubit and the Exodus format to help you understand why Cubit works the way it does. We'll talk about the strengths and the limitations of Cubit and about how to do mesh export. Our presenter will be Greg Vernon. If you've been to our other webinars, you'll know him. And I am Kimberly White. Coreform is a simulation software company. We are the exclusive commercial distributor of the Cubit meshing software, which was developed by Sandia. We are also the developers of Coreform IGA, which is an isogeometric analysis solver. Feel free to contact us if you're interested in learning more about that. And if you ever have any questions about Coreform or any of our products, you can reach us through the forum. So I'm going to start with a brief overview of Coreform Cubit, advanced meshing for challenging simulations. Cubit can do CAD import and cleanup. We have a broad set of cleanup tools. It does semi-automated hex meshing, and it gives you maximum control of mesh properties and mesh quality. And importantly, we also have a Cubit scripting language and a Python API that gives you a lot of control and power. So that's the brief overview. Greg, let's turn it over to you to walk through the rest of the webinar.
All right. Thanks, Kim, for the introductions. So yeah, as Kim says, let's go ahead and dive in and talk about why you would choose Cubit or choose Coreform Cubit.
And by the way, if you have any questions, just drop them in the chat and I'll make sure they get answered by Greg.
All right. So many of you have probably heard of Cubit. For those who haven't, Cubit is a general purpose meshing software. It is used by thousands of industry, government, and academic users. Cubit and Coreform Cubit, they're really based upon the open source mesh format Exodus, which enables then some general purpose meshing workflows. We're going to talk a little bit more in detail about the ability for Cubit to then import neutral as well as proprietary CAD format, meshing through like this Exodus-based workflow, and then the ability to export to third-party mesh formats like Abacus IMP files, lsdyna.k files, and so forth. I also want to mention or point out that another reason why you might choose Coreform Cubit is that there is a free educational license called Coreform Cubit Learn. It's fully functional with one limitation that it's limited to 50,000 element exports. But for students who are trying to learn a meshing tool and trying to learn a finite element or CFD solvers in their academic work, or for a hobbyist who's trying to get better at Cubit and getting better at using open source or commercial finite element solvers, Coreform Cubit Learn is a great tool for you to be able to learn that. And you can find how to get Coreform Cubit Learn on our website. So Coreform Cubit supports importing a variety of neutral as well as proprietary CAD formats, as well as mesh formats. Mesh formats don't tend to be proprietary, but sometimes they're not necessarily as open with the definition of them. Oftentimes, the definition is in a solver's manual. By neutral CAD formats, I'm referring to the ACES, STEP, IGES formats where these are kind of standards that are out there or at least shared. And they're visible in a neutral file format. So many CAD softwares can either import or export these formats. And then we also support then proprietary formats from, say, SolidWorks, Parasolid, Creo, Creo, CATIA, and NX. And then we also do support importing some faceted CAD formats like the STL file. This is only a partial listing. The full list would be too long to put here, it'd be too hard to read. So if you'd like to see the full list, of translators, you can go to our documentation page and search under the translators section there. As I mentioned on the mesh side, Cubit natively supports Exodus. It's based around the Exodus file format, which is an open source mesh format, but then we also can convert or export to different formats that you see here, like the Abacus, Fluent Mesh files, Idea Universal files, and Impetus, LS-DYNA, Nastran, and Patran. So between the different mesh formats we do export to, you're almost certain to find a format that works for your solver. So I wanted to give a little bit of history behind Cubit so you understand why Coreform Cubit works the way it does, and why it may be a good tool for you. So Cubit was initially developed by Sandia National Laboratories. It's now co-developed by Coreform. And then Cubit is now the distribution that's approved for government use, or United States government use. And then Coreform Cubit is then the distribution for commercial and academic use. So while the original Cubit has some limitations on distribution, especially outside of the United States, Coreform Cubit does not have those same limitations. Cubit was designed to support these various different codes that the national laboratories were developing around the turn of the millennium. And there was a bunch of these different codes across Sandia, as well as the other US national laboratories. Wasn't maybe really clear which ones were going to win out, and we didn't want to support a whole bunch of different mesh formats. So it kind of all coalesced around maybe this one tool and this one file format, which was called Exodus. And this Exodus mesh format was designed to be agnostic of these different simulation codes. So as long as the developers of those codes kind of centered themselves on Exodus, they would then have a preprocessor that they could then trust to be able to run their simulations, whether they were doing a fluid simulation, a heat transfer simulation, a structural mechanics simulation, electromagnetics. They could all use this same format and then the same workflow. So really, Cubit was designed around supporting Exodus. And that's something to keep in mind. You see that all the time as we're using Cubit. You see that lineage pervade through Cubit. And so just to get out my really good meme here, that you really should think of this as the epic handshake between Exodus and Cubit. They really want to work together. So let's talk a little bit about Exodus. Exodus is an open source mesh library, as I mentioned before. It's used by the US Department of Energy National Labs, as well as open source codes as either a supported mesh format or the native mesh format for several codes. So some of these here from the national laboratories are Moose from Idaho National Labs, which itself is open source. You can find it on GitHub. Truchis from Los Alamos National Laboratories, also open source. You can find its repositories on GitHub or GitLab. Sierra is a suite of physics solvers at Sandia National Laboratories. It is closed, but it's a very powerful set of tools there. And then there's also Nalu, which is a low-mock CFD solver from Sandia National Laboratories, which is open source. You can find it on GitHub as well. Additionally, as Exodus was being built up as a mesh format that supports not just the mesh input, but also the output from results. That's a really big key with Exodus, is it's not just about storing your mesh, but if you then have made solutions, you've got maybe stresses and displacement, the Exodus format supports those in this exact same file format, supports those results in it. And so then ParaView was developed also by an initial effort between the national laboratories and Kitware, and it has very strong support for Exodus in it. And there's also the Visit visualization tool from Lawrence Livermore, which itself is also open source. And then another reason around Coreform Cubit and Exodus in particular is that because Exodus has been around for so long, it has a broad ecosystem of tools that support it. So there's a few of these. I'll show you the website maybe after this presentation, just so you know how to find the CCUS project. CCUS is actually the Sandia project that owns the Exodus format, as well as these various different tools that you see in the left bar, this black bar here in the picture, just a listing of the tools. But among those, you'll find a Python module that can directly read, edit, modify, create new Exodus files. There's an Exodus to MATLAB converter that can go back and forth between the .mat file and Exodus. As well as there's even I think a set of tools like code that just directly accesses the Exodus file. There's even also a converter to take the binary Exodus format to an ASCII text human readable format, and back and forth. So really you have, with those three tools right there, you can pretty much use anything that's out there, whether it's a text editor, Python, MATLAB, tools that support those formats, to directly access the data in Exodus. So there's also tools in this listing here that do parallel decomposition for you. There's a decomp tool. So if you want to run on multiple cores, you want to split your mesh across the cores and load balance them, Exodus already has a library for that. The Exodus format then also supports parallel I/O, so parallel read and write. So if you've got large simulations that you need to visualize in a parallel pair view session, Exodus supports that. And there's even the ability for maybe third-party solvers, or if you have some internal tools you're trying to do verification on, it even supports a diff comparison, so you can tell whether or not your maybe your continuous integration pipelines have resulted in differences in results. And there's a lot more of capabilities that are supported by this CCUS ecosystem. But what I have typically found is that whenever I think I want to do something new, there's almost always a CCUS tool that already does it. And so it helps you avoid having to redo a lot of stuff. And so because Coreform Cubit was built around Exodus, it then uses these Exodus conventions. So on the left here is just a picture of, in this case, a reactor pressure vessel. And I've assigned, if we look here, I'll just zoom in, that there's this idea of having blocks, side sets, and node sets. These are terminologies that come from Exodus. And then I'm looking at one of the blocks that I've assigned. And in this block, it's asking me what element type I want to use. These element types are defined by Exodus. It also has things like, say, element attributes, Exodus variables, and it's looking for information. So the values you put into the element attributes then also are related to Exodus. So if you look through the Exodus manual, not only will you find node orderings, but you'll then find that for the different kinds of elements, what are the different attributes that you can give to them? So for a beam, you may need to define the area, first and second moments, stuff like that. For shells, you may have to define thicknesses. So there's a strong connection between creating your mesh in Cubit and then those Exodus conventions. And again, you can find these in the Exodus manual, which we distribute along with Cubit. So now just a few strengths of Cubit. Cubit really is a standalone meshing tool that works really great when you're combining it with external editing of input files. So many of us maybe start our lives in FEA using a GUI tool and doing everything inside of a GUI. But I think many of us, as we've gotten further along in our careers, we find that sometimes the GUI tools kind of slow us down. We have a large repository of previous problems that we've run, and I want to do just maybe a simple modification on one of those problems. And so we oftentimes are passing around templated files between groups or between people. And really the only thing you need to do is modify a couple things and then just provide a new mesh. And so in those kinds of cases, Cubit, it kind of cuts out a lot of the other things that are in the way to just allow you to focus on building the best mesh you can and not be limited in the mesh that you can produce because you have or need all this other kind of GUI stuff around it. We've mentioned a couple times now that it does contain this Python interface, which allows you to use or access Cubit with Python either inside of an active Qubit session or having an external Python environment that can then import the Qubit functionality and run Qubit internally, just like it would with any other module, and then continue on with it with the rest of its operations. And this Python interface is enabled by the geometry kernel of Qubit, which is ASYS from Dassault Systèmes Spatial. And it provides an incredible amount of geometry queries, as well as mesh queries that can help you prepare your model. When you then look at all the different tools that Qubit has for hex meshing in particular, it really does have best-in-class tools for, again, a semi-automated, so manual process. Fully automatic hex meshing is not yet known if it can be done. But there's a kind of a quote that I've kind of thrown around, I've heard said a lot, which is that if you can't hex mesh it in Qubit, it just can't be hex meshed. The amount of decomposition and cleanup tools that Qubit has really do mean that you can pretty much mesh anything that there is, if it can be at all. But it's not just about hex meshing. We also do support meshing 0D, 1D, 2D, 3D, quad tries, hex wedges, tets, pyramids. It has a kind of full assortment of elements that you can use in your mesh. And then the last thing I'll say is that it excels as a direct modeler where the focus is precision. And so direct modeling, we oftentimes think with modern CAD tools, I can just like click on a surface, pull and push, which is maybe more around a designer focused workflow. In Qubit, you can do those exact same operations, but it does focus a bit more on putting in values into functions to then execute to make those changes. Also from some of its history, because it's a direct modeler, it does not do feature-based modeling. It doesn't have the idea of having a tree of features where this is a bolt. You instead build journal files up that issue the commands that do the direct modeling one by one, as well as it's not really an assembly-based modeler. It doesn't have an idea of having an assembly of parts. Instead, it's a generic geometry modeler where you have an assortment of volumes. Typically, what I see in workflows is that typically you'll open up Qubit to mesh a single part kind of at a time, and you'll mesh that one part, and then you'll open up the next part and mesh that next part. You can bring an entire assembly into Qubit, but then there's maybe some manual effort to make sure that you separate out your regions into their separate parts. It's just not a native feature of Qubit. But I want to talk a little bit about that power of Python, which really I think is what allows you to reach the full potential of Qubit as a hex mesher. So in this case, there's a complex part to the kind of a pipe coming into a circular vessel, and it has this complex fillet at its interface. And the goal here is, for reasons of the geometry above and below it, as well as this particular geometry, is there are these vertices that suggest maybe a natural cut plane that's not aligned with this elliptical, or what appears to be an elliptical curve. And this curve is also not an ellipse, it's actually a spline curve. So what I want to do is I wanted to have a cut that was cutting not based on these curves that maybe are implied, but rather I want to cut through the point of this ellipse and cut it in half there. And so what Coreform Cubit and Python allow me to do is write a small function using SciPy, so the scientific Python module, using its optimized library. So I don't have to write my own optimizer. I'm able to use the ASYS access through our Python interface to do things like grab a curve as an object and then compute the curvature of that curve at some fraction along the curve's length. And so a simple lambda function, throw it into my optimization. Obviously the fraction goes from 0 to 1, and then return out the value. And then suddenly, to find the fraction on that curve, to find the maximum, or the location of max curvature, which is that point, is just a single call here, which I can now reuse on future projects that might have similar issues to this problem. So now I've built myself a tool in my toolbox for me personally that gives me an advantage over my competitors. I can share this also with the rest of the members on my team. And then using Python F strings to then execute the Cubit module in Python to perform my cut. So I do this all the time where I'm always building like these really small focus tools and not having to rewrite optimization or other libraries, right? Maybe I want to access some machine learning or fast Fourier transforms. I don't have to worry about doing that myself. Because I have Python, I can go up and grab that functionality from wherever I want. So also we've talked about that Qubit has this incredible amount of different tools for decomposition, for hex meshing. So just here on the left are just the web cuts for volumes. We also have web cuts. We call them web cuts, but a web cut is the Qubit language for, say, decomposition or partitioning. And so we have web cuts for volume, surfaces, curves. And so this is just a listing of the web cuts available for the volumes. And you can see here, if we pick, I want to sweep a surface, then I also get a number of other options for, what direction do you want to go in? Do you want to provide a vector? Again, I can compute that vector, maybe using Qubit Python to find the angle of a curve or the direction of a curve that's in my model. I could rotate about an axis. I can go a certain distance. Do I want to go through everything, just through the next volume to a specific surface? Do I want to just easily go in the perpendicular direction? There's all of these different tools that are in here that then for all of these different web cuts, like explode them out into a number of additional types of web cuts. And it's that flexibility that gives Qubit a lot of its power. Similarly, for defeaturing, we can do defeaturing on volume, surfaces, curves, vertices. In this case, I've chosen, maybe I want to remove a fillet type of surface or a blend surface. So I've chosen to remove a surface using extend. I want to try to get rid of maybe an entire blend chain, so maybe an entire fillet chain. And maybe if I've selected multiple different surfaces, I want to remove those connected sets. So again, a whole bunch of options here on how you want to remove a surface. In addition to this being a real operation, there are some virtual topology types of operations, such as compositing. When they're a virtual topology, there will be a little message that will say in the command panel that it's a virtual operation. And so this is another example of then cleanup for defeaturing is on the volume, we have these cleanup tools. In this case, I want to check for blend surfaces. So I've searched my model, it's found blend surfaces, and then it's suggesting solutions for me for how to remove those surfaces. And in the case where there's maybe 10 or 20 different solutions, you can scroll through or select the different possible options and see a preview of what that operation would do. So this is another tool that gives a lot of power to Qubit for being able to do hex meshing. And then it's not just about being able to decompose a partition or geometry to support, say, hex meshing or get yourself at least fewer elements, but it's also about how many types of elements can you create and what kind of schemes do you have. So here we're just going to follow that we want to mesh a volume. And so if I choose I want to mesh a volume, and for surface, curves, vertices, a lot of these same options exist, but I could choose like the mesh size. If I've already built a mesh, I can look at quality or smoothing the mesh. I can copy the mesh from one volume to an identical volume. I can refine my mesh. I can do renumbering if that's important for doing assembly-based modeling with a larger team. But here, so I've chosen mesh. I then have a multiple amount of different meshing schemes. In this case, I'm going to do a tet mesh. The other schemes here are hex mesh routines. And then within that tet mesh, I have a lot of different options for how I want the surface to be meshed. Maybe on the volume, maybe I want to make sure I always have 3 tets through thin members. I can specify growth rates, optimizations I want. I can try to minimize maybe some poor tet, so like over constrained tets and edges. A lot of different options here as well. So with everything, we kind of are giving max power to the user to be able to really create your element. And even out to if you need to modify individual elements for some reason, like pull and push a node, all of that functionality exists here as well. So maybe to amend my previous statement where I said if it couldn't be hex meshed in Qubit, I'll even just say that if you can't mesh it in Qubit, it just can't be meshed. With the assortment of mesh schemes, cleanup tools, partitioning tools, it really is a one-stop shop for if you need to mesh challenging parts, you can trust that Qubit, if it can be meshed, Qubit is the tool that can mesh it. And so you don't have to feel like you're leaving capability on the table. I want to talk about a few limitations, which again, a lot of these limitations come from just the history of Qubit and what its focus was. One thing is that Coreform Cubit does lack robust card generation for boundary conditions, contact, setting up linear and nonlinear solvers, physics problems. And that's primarily because Qubit was built to be a meshing tool. In certain cases, we've added some generic functionality for these conditions, but all of the different simulation codes that are out there, they all have different names and terminologies, different ways they apply these different conditions. They have different sets of linear nonlinear solvers. Some codes don't even have nonlinear solvers. And so it would be intractable to support all of the simulation codes in this one tool. And so Qubit primarily focuses on just being able to do the meshing and not doing the simulation input. There's some stuff that's out of the scope of this presentation or this webinar, but if you are interested, you can actually extend Qubit to then be a full preprocessor for your solver. If you're interested in knowing more about that, reach out to us. We can have that conversation. And we do that with a number of our partners, in fact, building these tools for them. It also does not have built-in post-processing. It's primarily a meshing tool. It's not this all-in-one, as I mentioned. And again, Qubit being based around Exodus, since pair view is already a great post-processing tool for the Exodus format, it wasn't really necessary to have that in Qubit. It also does not have a 2D or 3D sketcher interface, which you may be familiar with. However, in the past, I have used Python tools in pinch. So I've used tools like FreeCAD to create sketches for me, and then through Python, pull those back into Qubit. It also does not support local coordinate systems, which you may be interested in using for doing anything from defining material orientations to defining a output coordinate system that maybe you want Cartesian and cylindrical coordinate systems in one. That's not supported by Qubit, as well as we don't support polyhedral element mesh generation, even though technically that is supported by Exodus. So especially in low Reynolds CFD, you're starting to see more of these polyhedral meshes come online. That's not supported by Exodus, not supported in Qubit. I will say that I did at one point in a former life write a polyhedral mesh export by exporting the dual of the TET mesh. And so I wrote that all in Python. Again, because I had Python, I was able to build that solution for myself. And then a final note here just on then exporting from Coreform Cubit to the third-party format. As I mentioned, Qubit does best support the Exodus formats, but in Exodus, elements only define the number of nodes. All the decisions about the quadrature or special formulation ideas like hybrid formulations, selective deviatoric quadrature schemes, reduced integration, full integration, those are Exodus expected those provided by the solver. And so many of you might be aware that there are third-party mesh formats such as Abacus that combine nodes and quadrature or formulation information into the mesh or into the element type. And so, for instance, a C3D8 is a hex 8. C3D8I is a hex 8 with incompatible modes, R reduced integration, H hybrid, IH incompatible modes, hybrid formulation, which again, you might be using those for explicit analyses, like explicit dynamics, or maybe a problem with nearly compressible materials. You will need in those formats to then modify the element formulation output from Qubit to match the specific formulation that you need for your code. So that's just one big note I want to make sure is clear. With that, that's all I have today. So I guess I'll go ahead and open the floor for questions or comments if there's any, Kim.
We don't have any up yet. Feel free to use the chat or the Q&A button at the bottom of your screen.
I do see there's a Matt Kamer raised a hand. Don't know how recent that was.
All right. Well, if there are no questions, thank you, Greg, for running. Oh, we do have one. Greg, does it make a difference whether you import using ACES or STEP?
Yes, it does. What I would say is that just in general with CAE tools out there, you want to minimize as many CAD data translations as possible. And so if we export out, so if you have a tool and you export to STEP and then import that into Cubit, because Cubit is based on ACES, it has to translate STEP into its native language, essentially. And so now you've had one CAD tool try to translate its native language into a neutral language, translate that neutral language back to a native language. And there's almost always information lost in between. So if you have a tool that exports ACES, so maybe you have SolidWorks and maybe SolidWorks supports an ACES export, then that is maybe one translation. Because I don't think SolidWorks is based on ACES. I think it's Parasolid, if I remember. But that's one translation. But now Cubit doesn't have to translate, right? It's in its native form. So you've cut out a translation stage. What I would say is that what's even better is that say you have SolidWorks and you then have Cubit, is to use the data translator that just is the SolidWorks importer. So then your SolidWorks, you could export the SolidWorks file and then import the SolidWorks directly into Cubit and put the translation stage at that point. I think that's the preferred route to go. But obviously in practice, neutral files are so easy to hand around that that's oftentimes all we have. But if you have an option, if your two options are to either export import STEP or export import ACES, choose ACES. But by far the best solution is to use a direct data translator.
Greg, we have a comment suggesting that users can use Meshio to export to most file formats. Have you used that before?
I have used Meshio. That's actually a really great tool. It's on GitHub. It's open source. I think the user is like Enshlo, so I don't know if he's on this call or not. But yeah, Meshio, it's a Python base as well, and it can consume Exodus as well as like INP files and stuff, and then translate to different formats. So it's also a great tool. If there's a format that's not supported by Cubit, you can pretty much use Meshio to then fill the gaps. I will say that Cubit tends to be pretty good at exporting to the third-party formats it does support. But again, there's obviously way more formats that could ever be encapsulated in a single tool. And Mesh.io probably has the largest that I've seen of just translating mesh formats. So that's a really good note to call out there.
And someone has asked if Cubit offers trial licenses, and yes, we do.
Yep. So in addition to
30-day free trial.
Yep. And that's a separate thing from the Cubit Learn that we talked about earlier. Yep.
Are all functions available using mesh-based geometry?
No. So that's one thing we didn't really talk about today. So Cubit does have some basic capabilities for importing like those STL files. One of the problems with faceted files or mesh-based geometries is that they've become faceted and you've lost information about the original geometry in many ways. And in many cases, they're not necessarily even watertight. And so there are certain functionalities that just aren't supported on the mesh-based geometry. The way I'll say that mesh-based geometry has really helped me out on several problems where I've really been in a bind and I've needed that functionality it's not something that I would base my entire, if I had like a consulting agency, I would not base my work around using mesh-based geometries. But it does have it in, for cases where, I just need to import an STL file. I want to build a temp mesh. I want to assign a few side sets and node sets, and I want to export it. That it's really good at doing.
We have a few more questions, Greg. So first, is there any improvement on parallelizing?
Yeah, so the temp mesher that we provide does have some multi-threaded functionality for parallelization there. I'll say that the kind of the advancing front approach that we use in Cubit doesn't always, or isn't necessarily the ideal for parallelization. So I don't think we've done a lot of parallelization there. So I would say in general, meshing in Cubit is generally a serial process. We do have what's called a sculpt, which is a parallel hex mesher. It's kind of akin to like snappy hex mesh from OpenFoam, where it starts with a voxel background grid and then tries to refine on surfaces and kind of sculpt mesh nodes onto a surface. But again, the hex meshing problem is an unsolved math problem. And so even sculpt does not always give you a valid hex mesh. And oftentimes my experience has been, again, that sculpt has got me out of binds. It does tend to put poor elements on surfaces, which in a lot of my work is where I care about having the highest mesh quality. So it's certainly something to look into, and it is fully parallel. You can run it on thousands of cores on a supercomputer. And so there are definitely applications where sculpt is not just beneficial, but absolutely needed. But as far as the traditional meshing in Qubit, it is not really parallel there. So hopefully that helps answer the question.
Yeah, the question asker was saying that it takes hours to run a Python script, even on terminal. Any way to improve that?
Yeah, so that'd be something that would be interesting to take a look at. One thing I might mention that is potentially something to look at. Oops, it's like my computer screen here is freezing up on me. Give me one moment. Is in Python, one of the things I've done here is rather than say doing qubit.curve curve ID dot curvature and then qubit curve curve ID dot position from fraction, as opposed to doing two, doing this in a one-liner, I did move this out. I created the object once and then just called the methods from it. The more you have to like traverse along a path like this, that can impact performance. So the one thing I'll just check that I see probably in 90% of the performance issues with the Python API is that you're doing a lot of traversing. I would kind of pre-allocate's not the right term for this, but kind of like pre-allocate your object that you would then want to evaluate. Just see if that might give you some performance boost. If you are interested in having us take a look at your Python script to see if there's maybe some things that could be sped up, you can reach out to us, or if you can post it on the forum, we can give some help there too. But that probably covers maybe 90% of the issues that I see. I've also not looked into what some of you may be aware that Python is removing global interlock with some of the newer versions. I don't know what that means yet for Qubit. So I don't know if there's any of the Sandia Qubit developers on here who can answer that for me. I don't think that Qubit is thread safe in that manner, but that's something that we'll certainly have to take a look at in the future.
In terms of Qubit licensing from Sandia, which is government use only, do you know if government subcontractors can access Sandia Qubit?
Yeah, so I won't answer for Qubit or for the Sandia folks. I don't know specifics. What I will say is that if you go to their qubit.sandia.gov, they do have a section here on licensing. I will say that I do know of non-government agencies, so commercial companies who are executing projects for the government, I do know that they have what's called a government use notice. So I'll defer to whatever the Qubit licensing webpage says is the official word, and you can reach out to them to find out more information. But there is a good chance that if you do have an official U.S. federal government contract, that you may be able to use Qubit.
Okay. And finally, they're wondering if Coreform offers expert meshing services.
We do offer expert meshing services. There's a couple ways to do that. One is by posting your questions on our forum, and then not only can we then answer, give you an answer through the forum. It's visible then to everyone, so more people can learn how to solve challenging problems. And then also through your Qubit license, you can send us a message to support@coreform.com. And then if you're interested, we're always interested to hear proposals about maybe dedicated consulting support on challenging meshes. So for that, it depends, but we love helping our customers with building meshes. They're I find them enjoyable to mesh. It's like doing my morning Sudoku.
And Greg, there's also a question, is there a difference between the licensed version and the academic version?
No, there's no difference between the full commercial version of Qubit and the academic version of Qubit, or the academic license of Qubit, other than the price and the allowed uses. That Qubit Learn is fully functional. The only limitation is you can only export 50,000 elements. If you want the free learn, if you're wanting to use the free Learn license in your academic studies for a little hobby project you're trying to do to become more familiar with Qubit, that one's fully functional with that one limitation.
And if you're using it as an academic user, again, you have no export limit. Use the full academic license. Correct. And it's identical to the commercial. We will verify that you're an academic user, but the functionality will be exactly the same.
Yep.
Okay. That's all our questions, Greg. So I'd just like to thank you all for attending. We hope this was helpful for you. If it looks like Coreform Cubit is not going to be the tool you need right now, that's great. We're still glad you came. And if you run into a problem in the future that no other tool can mesh for you, I hope that you remember Cubit. And if Coreform Cubit does seem to be the right tool for you, then please feel free to reach out, request a free trial, and contact on our forum or sales@coreform.com if you'd like to talk about purchasing a license. Again, we thank you very much for attending. Have a great day, everybody.
Thank you.